Okay, so the k weakest rows in a matrix given a m product and matrix, it's called math, of ones representing soldiers and zeros representing civilians, retain the indexes or the indices of the k weakest row in the matrix, order from the weakest to the strongest. Here they give us the conditions where a row is weaker. So a row I is weaker than a row j if the number of soldiers in a row I is less than the number of soldiers in row j, so obvious, and or they have the same number of soldiers but I is less than j, so the indices. Soldiers are always stand in the frontier of the row, of a row. That is always ones may appear first and then zeros. So as you can see in this case, so it's always zeros then ones. I'm not sure. I believe maybe some cases that will have only zeros. Let's look at the constraints. Um, okay. Yeah, so according to this rule, I think so. Yeah, there are some cases, maybe all of them are ones or all of them are zeros, but ones will appear only before zeros. So it's like it's kind of sorted. You can think about it if you think about it. Um, so the way I can solve it is to use binary search, and I think I will just start write the code, and maybe I will try to explain as much as I can. So first thing, I will write a function that should divide and conquer, like the binary search. So const find the split. So there is a place where if you go to the right, you will find zeros, and if you go to the left, you will find ones. Or, for example, if the array is only contains with one element, which is one, this is itself the split position, you can say, or the position where left to the right to the right is not equal, and the left is equal or undefined. You can something like this. Okay, so this is a function, so which should accept an array. I can just hide this. So this will accept an array, a left and a right. First thing I will find, so this is something you usually do in binary search. So math dot seed, so left plus right over 2, and then so if so yeah, I will just show you the conditions that we would keep calling the function recursively on. Then I will show you the two stopping condition we will have. So first thing, if the index of array mid, sorry, if the element of the in the indices mid, so if the mid element is equal to 1, we should return find the split itself. We'll pass the array starting from mid plus 1 to the right. So if you think about it, if we found 1, okay, let's go and now search the right section, else we will search the left section. So array left mid minus 1, and we will keep doing that until we found a position where left is equal to right. So when we found that position, this means we found the split, you can say index. We found the split index where the value is either 1 or 0. Yeah, and for example, if it was 0, the left of it is all, if it was 1, the left of it is all 1, the right to it is all 0. If it was 0, the right to it is all zeros, the left to it is all ones. So this is what I mean by this. The left is equal to the right. So in this case, we should return mid plus, and this might be a little bit weird. So I will check if the element in this index, right or left, because they are equal, doesn't matter, is equal to 1, I will plus 1 to it, else I will just plus 0. Because if you think about it, mid represents the index, which will always be minus by 1. So we need to return that one. So by default, we should always plus 1. But because we don't need to count the zeros, so I will check if that is 1, yeah, count a 1. Add 1 to it. If no, just add 0. And there is another condition which I will try to show you. So this is not always the case. So there is some conditions where at some point left would be bigger than right. In that case, we should just return left. And I will give you an example for that case. So the way I found these two stopping conditions, that I just kept doing examples on paper. Then I found these two stopping conditions. I'm not sure if my approach is correct, but this is how I found them. This is basically it for the recursive function. Yeah, and let's now write the body here. So first thing, res is equal. So this is a variable to the matrix dot map. So I will map. So it's an array. It's an array of arrays, and I will map it. So first element I will call it A. Then the index. I will just return. I will return an object. So val is the find the split function, the return value of that. Oops, I forgot the return here. Yeah. So okay, the return value from A. So each index will map to an array. So the left is 0, and the right is A dot length minus 1. And also I will return the index itself. So I will keep that. Okay, so after I've found this res array, which should be an array of objects like this, I can simplify this. Maybe the code will look more shorter. Yeah, like this. Like this. Yeah. Does it make sense? Yeah. Okay. So I will map the array of the matrix to array of objects. Then I will sort the array. So res will be equal res. That's why it's I defined it with let, not const. So res dot sort. I don't need a body. So A, B. First thing, if A dot val equals B dot val, I will sort them by the indices. So this is this condition, this second condition, or they have the same number of soldiers, but I is less than J. So this is it. So if they have the same number of soldiers, which is val, I will sort them by A dot I minus B dot I by the index. Else I will sort them normally by the number of soldiers, dot val minus B dot val. And now define array called final res empty array. So array from length of k. I like if I want to do something for a couple of times, I like to create an empty array for it and use for each. Not sure if this is faster, but yeah. Okay, so I don't care about the elements since they are all defined. You can put underscore. This is a common practice. And I care about the index. What I will do, I will push into the final result array res the sorted array of objects of index I dot the index itself. So I want the index of the weakest the index of the weakest what is it called? This represents an army, like row, sorry. Yeah, the index of the weakest row dot I, which that's why I saved it here. So this is one reason, and the second reason so I can sort it. And yeah, you can also simplify this like this. And then just return final res. So let me run it. Okay, submit. Okay, so it's pretty much good. It's not that bad. Let me just show you the cases. So most of the cases will fall into this one when left is equal to right, but some cases will fall here. So I will show it to you in the debugger. So I have a couple cases. Let me comment. So the first case is where left is less than right. All of them, the rest of them is all left equal to right. But let me run it in the debugger. Yeah. Okay, so we define this matrix. Okay, and I then called find the split. And there's a couple of differences, but it's the same function. Okay, so let's go forward. Mid is 2, which and the value in that index is 0. So this one. Okay, let me show you the local. So left is 0, right is 4. Let's go another step. This will fail. This will fail, and this means we will go check the left side. So we will check this side, the 1 and the 1. Let's go. Mid is 1 in this index because left is 0 and right is 1. Go. Yes. So will fail. This will be true. So we'll go and check the right section of the array, which is, if you think about it now, mid plus 1. Mid is 1. So from index 2 to right, which is 1. So left is 2 and right is 1. Left is bigger than right. Go. So if left is bigger than right, in this case, just retain left, which represents the number of ones we have. So that's it. That's why we have this condition. Okay. So this should now return. Go. This is the second time we called the find the split from the beginning for this array, which has only one element. So if you go to, so yeah, left is 0 and right is 0. Go mid is 0 also, and the value for that is 1, which is the only element. Left is equal to right. We will return mid, but mid is 0. So this is one also of the reasons why we need to check if that element in that index is 1 plus 1 to it, else 0. So that is 1. Yeah. So anyway, so that's it. I hope this was helpful. Yeah. Anyway, thank you.